over direct and inverse variations today as we start to get into our rationals lessons. So direct variation is a linear relationship having the form y equals kx. And what that means, if one gets bigger, so does the other. And if one gets smaller, so does the other. So the same thing happens to both variables, x and y. We also have something called the constant of variation, which is that k you see. It's a non-zero constant in the equation above that basically relates the two variables together. K cannot be zero. As long as you have an x and a y, you can find the constant of variation k for that situation, and then you can write an equation using that constant in terms of x and y. So a couple examples, we have 2 points. We have 2, 4, and negative 3, 5. So the direct variation equation for both is just y equals kx. And then we will use the values we have here. So in 2, 4, we would say 4 equals k times 2. We find the constant of variation by dividing each side by 2. So we have k equals 2, and then we plug the k value back in, and now we have our direct variation equation, y equals 2x. That's for the equation on the left. For the equation on the right, that's negative 3, 5. We still use y equals kx, and we plug in our values. 5 equals k times negative 3. That means to solve for k, we have to divide both sides by negative 3. So k equals negative 5/3 in this case. So our equation is y equals negative 5/3 times x. So that's just very simple and easy direct variation. So now, how can we determine if a set of points in a table or set form makes a direct variation? You have to check to see that every point has the same constant of variation. Remember, when you are finding when it's direct variation, you divide k equals when you find direct variation. I can't remember the exact answers here. For direct, oh, that's bad. Let's get rid of that. For direct variation, it's k equals y over x. And I can't remember what I said, but just know it's k equals y over x. If the entire set or table is direct variation, then we can write an equation for it. So if we look here, I like to find my k sub 1, my k sub 2, and my k sub 3. So k1 is 6 over 2, which is 3. k2 is 12 over 4, which is also 3. And k3, 18 over 6, which is 3. So then we can write our direct variation equation as y equals 3x, and we say yes, it is a direct variation. Because all 3 points work. Now, we'll try this one for direct variation. So remember, k1, k2, k3, and we have to do y divided by x. So for this first one, we have 0 divided by negative 1, which is 0. For the second one, we have 2 divided by 2, which is 1. For the last one, we get 4 divided by 5. So all 3 of them are different, plus k can't be 0. So as soon as you see that, you know it's not direct variation. And then once you see the first two are not equal, it's also not direct variation. So we say not direct variation. Okay. So now let's flip over to the other side of the paper. Let me get to my second page. Okay. And so it looks like the same as the front side, but now it's for an inverse variation rather than direct variation. So an inverse variation, think opposites. It's a linear relationship having the form y equals k over x. If one gets bigger, the other gets smaller, and vice versa. The non-zero constant k is still in the equation above, same as before. The k value still is giving us the relationship between x and y. As long as you have an x and a y, you can find the constant of variation k for that situation, and then you can write an equation. So we're going to actually use the exact same 2 points. And now our equation is y equals k divided by x. So we're going to plug these in here. So for 2 and 4, that means we're going to have 4 equals k over 2. K is equal to 8 because we have to multiply. And then y equals 8 over x. So then if we try the negative 3 and 5, we have 5 equals k divided by negative 3. That means we need to multiply both sides by negative 3. And we get negative 15 is equal to k. So y is equal to negative 15 over x. So how can we determine if a set of points in the table or set form makes an inverse variation? We have to check to see that every point makes the same constant of variation, just like with direct. Remember now, you do the inverse and we multiply x and y. If the entire set is inverse, then we can write an equation for it. Okay, so now with our k values, we have to multiply x and y. So k1, k2, and k3, I could just do this. I can multiply them. So I'm going to get 12, 12, and 12. So my equation is y equals 12 over x. It is an inverse variation. Okay, good. So let's take a look at there. Make sure you're showing your work. You give your equation. All right, second one. All right, so we multiply. We multiply. We multiply. So when we multiply this, we get 0. When we multiply this, we get 8. And when we multiply this, we get negative 28. So first of all, we know can't be 0. So we're done right there. If we forget that, then we know the first two don't match. So it's not an inverse variation. And one day I'll learn to write better, but until that day, we're stuck with this. So it is not an inverse variation. And then we're going to look at, I don't want to do 6 because it's a bad example. We're going to look at 5. Are these direct, inverse, or neither variation? If direct or inverse, then write the equation for it. So kind of the rule of thumb is if both the x's and y's are going in the same direction, getting larger or smaller, try your direct variation. If one is getting larger and one is getting smaller, then try inverse. So we look here, x's are growing and the y's are growing. So I am going to try direct variation, which means my direct variation equation is y equals k times x, which means k is equal to y over x. So when I do that division, I get 3 for here, negative 6 over negative 2, 3 over 1 is 3, and 9 over 3 is 3. So this equation is y equals 3x, and it is a direct variation. And there you go. So direct and inverse variation, pretty simple concepts, and hopefully now you feel the same way.